KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Hi, welcome to Homework Hotline. My name is Ken Pinkerton. I'm a retired science teacher from Zane Middle School.
And my name is Rita McConaughey. I am a math teacher with Northern United Humboldt Charter School. And you're watching Homework Hotline.
Woohoo! On
Yay.
KEET TV. So we're here to help you with your math and science, give you some ideas. We're trying to coordinate with teachers out in the community on topics of math and science. And Rita is doing slope.
Yes.
And so...
A couple episodes back, we did something called rate of change, and it was related to the candles, how the candles shrank over time, and we measured that, and then we could see how the lines, when you connect the dots and the data points, then it was a slope, and we connected that to the rate of how it changed. And really, slope is so similar to rate of change that we're now going to focus more on slope today.
And where you can find it.
Mm-hmm.
Right.
And we talked about some places we see slope. One of the things we brought up last time was about on a road, you may see this sign as you're driving down a steep hill or driving up a steep hill. More likely you'd see it going down, right? Because that's braking. Dangerous, right? And so trucks or heavy loads, they need to know what the grade is. And this 10% grade, Ken, you got this picture out on Highway 36,
yes.
Which is east of
Up
Fortuna.
by Ruth Lake, yeah.
Yep.
So it's on the way to Ruth Lake. I think they're coming back from Ruth Lake. So.
Okay, so you might see slope there, and then we talked about when you go hiking, you might see slope also. They give you a notification of how steep something is, be aware of that. And we talked about grades, right? The not grades you get, but the grade, the percent grade. Okay, so that was a previous Homework Hotline. You can go look at that one. But today we're going to talk more about slope, and we're going to end today with a skateboard park. We're going to try to design our own skateboard park, but you know, you have to have safe slopes anytime you're doing it. But I'm sure there's the daredevils that want,
it's like
really
when you're skiing, they have the black diamond and all the different designations for how steep. I think the steepness is a big part of how ski slopes are determined, and so they have the bunny hills and then all the way up to the black diamond, which indicates how steep it is and I think how many obstacles are on the way, that kind of thing. So it's an important concept in so many ways that hopefully you'll see. And
yeah, this was from last time. It dealt with rate of change and how the water filled the bowl, and then
cool.
And here was the graph, how you could see it. And with the candles, the rate of change, it was a decreasing rate of change, where the water filling was an increasing rate of change. And if you can see the slope, I call it a positive slope over time. So as the horizontal value got greater, vertical value also got greater, and so it goes up. Right. And in my classroom, I call that an up the hill slope. Up the hill slope, or
I always like to compare it to money. So the more you save, you get. It's a positive thing.
Right. You want a positive slope with
and if you're spending money, if it's yours, it's definitely a negative slope.
Okay. So I'm going to try to do just a quick review of math, and so I'm going to try to get to this screen perfect, and I'm going to write what slope is. Okay. So you can have different, let's see, does that show up good enough? It's okay. All right, so slope, a lot of times you'll learn that it is the rise over the run. Okay? the rise over the run. And we also call it the change in y over the change in x. And I think, Ken, we'll use your game to show where x is at and where y is at. Okay, I'm going to try to make my pen just a little bit thicker. So give me a minute to do that. So hold down on that. All right, cool. So let's try with 3. You think that'll be enough with 3? Okay. All right, so rise over run equals what we call change in y over change in x. And what's kind of neat, it looks like a triangle, doesn't it? But this is the delta, the Greek letter delta.
And that means change, right?
Yes, it means change in. Okay, so change in y over change in x. Oh yeah, that does come up much better.
Yeah, that looks
wonderful. Okay, so rise over run, change in y over change in the x's. And you'll see a formula that looks like this, y sub 2. When I say sub, that means it's a little number to the right, minus y sub 1 over x sub 2 minus x sub 1. So basically it's just taking your y values, minusing or subtracting them, the difference in them, and then dividing it by the difference of your x values. Well, what is x and what is y? So we're going to come over here and look at a game that Ken has. What do you call this game?
It doesn't have a name yet.
Oh.
Or it could be called the coordinate plane, I guess.
Okay, so he said it's a coordinate plane. I'm going to call it the XY, oops, let's see if I can get this. Coordinate. And we call it a plane, the XY coordinate plane, because it's a two-dimensional, it's a flat surface, okay? It's just our XY coordinate plane is upright. And before I go off the screen, I'm going to just draw one similar to what Ken has up there. And this here is called the x-axis. And this vertical line is called the y-axis. Okay? So those are some things let's keep in mind. And if you have ever played Battleship, you've done something with the XY plane.
Right. Except you use letters of the alphabet for one of the the coordinates, right?
And these are like two number lines. One's a horizontal number line and one's a vertical number line. Right. Okay, and so we see that with the blue lines here. Horizontal one is x, vertical one is y. Okay, so what are we going to do on our game?
Well, the game is to learn how about the coordinate planes. And so the way it works is like for this one, you push the button and this says 4, 5. So that's the coordinates. And then so 4 tells us what? The first number would be?
Okay, that's another good thing. Like when you're playing Battleship, you say it's, is it 1, 3 or A3?
Yeah, it's like A3.
Okay,
A3, yeah.
but so the A, I should have brought a Battleship game to really see. But one of them is the horizontal and another is the vertical. And when we're doing the XY coordinate plane game, our X numbers are first, our Y numbers are second. Right. Okay, so X is first, Y is second.
Okay. So this
you said the number
is 4, 5?
4,
5.
5. And then if I was in math class, I would just say, let's put a hug around it, right, with the parentheses.
So that means I go over 4, right?
Yep,
okay.
Over 4.
So I go over 4 on the X.
Okay.
So that's there, and then I'm gonna go up 5. Now with this game, if I did it the right way, if I push this button and push in this at the same time, the red light goes on for you.
And where will the red light be?
It's on top.
Oh, perfect, yay.
So and then if we want to, okay, so then if you want to pick another point, then we could create a slope.
Okay. So
Anywhere would be fine. I don't know.
is this,
That's 5, -3, so.
okay, so 5, -3, I'm pushing that button. On the x-axis, I'm going to go to where 5 is at. Now, where do you think I should go for -3? You went up for positive, down for negative.
Right.
So 1, -2, -3, and if I did it correctly.
Let's see, I'll push the button. Let's see which one it did.
Okay.
You can go ahead.
Put it in there?
Yeah.
Am I off
one more
a little bit?
I think. Or no, that's it. That was it. And then push in a little bit. Let's see, you might have to push in a little farther. And then, whoops, 5, -3. Well, let's see. 5, and then, I might have a bad connection.
Did you make this game?
Yeah.
Awesome.
And this is the first time it's been out in public, so it's going through its paces. So I might have a loose wire.
Okay, well, let's try a different one.
Okay.
Then. Okay. How about -1, 0?
Okay, -1,
So
0.
on the x-axis, I'm going to give it to you.
Okay.
Because it's on your side.
-1
on the x-axis.
Oh, there we go.
And then 0.
Right, would be right
So that
there.
means when it was -1, 0, he went back 1, but he didn't go up or down any because the y part was 0. So it was right on the blue line.
Now if I connect a line between these two, would that be creating a slope?
That would be creating a slope. And then that's where we get to use our slope formula to see what the actual slope is. Now, real quickly, I'm gonna use my dinosaur.
Okay.
Go ahead and put it out there. Okay, so just walking along, right? And let's say it's slippery. The dinosaur's not going to be able to,
right,
go down safely.
So it's a pretty good slope.
Pretty good slope. Same thing with a vehicle or a bicycle or a skateboard or even just walking down. You want to be careful if the slope is too steep. So let's get a little less slope.
Okay, I'm going to just make it up. I'm going to go 3, or I'm going to go 1, 3. So,
okay.
Or -1, 3, sorry.
Definitely a little bit better. Can go down it much safer. Okay, so if we want to calculate the slope of this line, we're going to take our coordinates.
So 4, 5, and -1.
Yeah, I'm just wondering what I can erase.
Oh, okay, sorry.
And just come up with a new page. Okay. I want to keep this, so I'm gonna go ahead and erase this 4, 5 first. Do we have 4, 5 on there still? Oh, we do.
Yes.
Okay, then I'll keep it there. Back to here. And what was the other point?
The other point is negative. Well, do you want me to keep them positive? I can do the same thing.
I
Okay.
could handle
-1, 3.
-1 is the x value, 3. Okay.
With hugs.
2 little hugs. Keep them in there. All right, so if I'm going to calculate the slope of the line that we created on our XY coordinate plane game, I'm going to take the y values and subtract them. So that's the second numbers. 5 minus 3. That's doable, right? And then I'm going to subtract the x values. Now you might wonder, well, which one should I do first? Since I did 5 first on the y values, I need to do 4 first on the bottom. Okay, now this is going to be a little tricky. You maybe won't realize or know how to do subtracting of positive and negative numbers yet, but I'm going to give you a quick tutorial. We get to change subtracting on this one. 4 minus -1, we get to change that to adding the opposite of -1, which is +1, okay? So adding the opposite, they have to go together. You can't just change subtracting to adding, it has to be adding the opposite.
Right.
Okay, so our slope is 5 minus 3 is 2. On the bottom, the denominator, we're going to have 5. So if I have the fraction 2/5, that is the slope of our first line.
Very cool.
Okay.
And then if I go up here, I think if I go over 2 and up 5, it goes right through there. So I think it matches it pretty well, or it would parallel it that way. So that would be on there.
Okay. So at this point, I think I will add another slide here because I want to show you. We're going to pick a different point along there. We're going to, we have where the pegs are, right? And those are the points you gave me. I want you to put a peg in another place somewhere along here.
You want steeper or?
No, we're going to keep the same
okay,
slope.
Same one. Okay.
We're going to keep the same slope.
But put another point?
Yeah.
Okay. Let me see if I can find a point that will go right
Yes.
there. How about -5, 3?
Okay. Let me catch up here.
I think that's going to be close anyway.
Let's see here. We'll stay there. Okay. Oh, I'm just playing over here. There we go. Whew. All right.
Toys.
I'm still playing. No. You know what?
got a
I'm gonna
little delay.
I'm gonna come back over here.
Okay.
So, if you eat pig, do you have another peg?
Nope.
Nope. All right. So
We
we're
can
gonna
use a
try to
pencil.
keep it right here.
We could use the
Is there
pencil.
another place where we could put the peg? Maybe
Right there? Yeah.
right here?
Yeah, that would probably.
Okay, and our slope would have been up to over 5.
Mm-hmm.
Okay, so maybe a little bit different slope.
Well, let's go. Let's see if we can do it. If we go over 2, so 1, 2, and then up 5, would that work that way? Or
Okay, so it's rise over run. So
Right.
we're gonna go.
Oh, it's going
We're
to be
gonna go up 2,
Right.
and then over
Over
5.
And that would
So
be
is that negative 5
yeah. So it would be 3 on the origin there. So
right there?
right here, I think. So up 2,
Yep.
that would be 3, and then over 5,
Yep.
that would be right there. Whoops, I don't have a
Okay.
hole in that one yet.
All
There we
right,
go.
perfect.
Yeah.
Okay, so the neat thing about when you have the slope of a line, even though we had the peg was over here before, we could have put the peg anywhere else along there that had the same slope where the rise was up 2 and then the run was over 5. So the vertical over the horizontal change.
Yeah.
Okay.
And it's consistent all along that line, so we could find any point on there then. And the tricky part is when it's not perfect, right?
Yeah.
that's and this leaves some a little bit of wiggle room for that too.
So I think when you're saying not perfect, like here where I have the marker, there's no hole there. I can't like put it right in there.
Right.
So there isn't an intersection
right.
that
That's a whole
is
number.
exact. That's a whole number.
Right.
It might be a fraction or a decimal.
Yeah.
Okay. So we have positive slopes, and if we could also do a negative slope where the line would go like down the hill.
Yeah.
Okay, we better design our
Want to move on to
skateboard
the
park.
skateboard park? Okay.
Yes. Okay.
So I get rid of this or move this out of the way?
I think so.
Okay.
Okay. So if you're at a skateboard park, you probably want to start level, right? And then you want to have a ramp. Okay? So I'm going to have a ramp start here. And you probably don't want to have to go up too far, right?
If you're going up?
Yeah, so
Yeah.
we're going to go up.
Right.
And then most likely we would have another level surface.
Right.
Okay? And then maybe we want to go down.
Yeah, if you want to drop into a bowl or something like that.
Right.
Yeah.
Okay. And maybe another level surface. Okay? And then you want to go back up. Okay? Something like that.
Uh-huh.
Does that look like a decent skateboard park?
Yep.
A good start?
It's a good start.
Okay. So then we'll probably have another level surface,
Right.
and then maybe they can go back down it, right?
Right.
Okay. So those different slopes, here we have a positive slope going up the hill. I'm just going to put a plus sign. What do you think this slope then is? If that one was up,
that's going to be a negative then,
negative
right?
slope. Okay. Another
that's going to be a positive slope.
positive slope. How about these flat lines?
Is there a no slope? Maybe.
There is a no slope. That is not a no slope though. Okay? Because watch what happens. So remember, slope is the rise over the run, right?
Mm-hmm.
Okay, so at a horizontal line, we're wondering what the slope is. Ken thinks it might be no slope, and I'm saying there is something called a no slope. We call it an undefined slope. This one is not no slope because there is a zero rise. It didn't go up or down, but there is some number for the run. It did go to the right. And what do you have when you have 0 divided by a number?
0.
How many parts of that number? It's 0, right?
Right.
Okay, so you said a no slope. That's going to be at the end of our skateboard. That is considered maybe a no slope because look at our rise. We have some number for our rise, right?
Mm-hmm.
But what's the run? Did it go to the right or to the left?
Right.
No!
So it's a 0.
0 run, and can you ever divide by 0?
Nope.
No! Even if you ask Siri, what's 0 divided by 0? She's going to say something like Cookie Monster doesn't have any friends and no cookies, and Cookie Monster is sad. Something like that.
Right.
So this is called, I mean, you might say no slope, but we just say it's undefined. Let me not go to the edge. Undefined slope. Okay?
Nice.
All right. So we could definitely put it on paper. Let's try to build something with it. So we have some ramps here that have different heights. Okay.
Do you want to do the long one or the short one?
I think the long one would work. Okay. So we have a long ramp we're going to try to build. I could put the short one on the other end.
Okay. Well, and then I figured out the slope for each of these if you want.
Okay, great. How'd you figure out the slope?
What I did was I measured the rise and the run, and then
Divided?
Yeah, divided it till I got a 10. So I have how many inches every 10 inches. So this is right now, as its shortest, this is about 6 inches. It starts 6 inches.
Okay.
And then it runs 38 inches from here, the circle, to there.
Okay.
And so the slope would be 2.3 over 10.
Okay. And I think if I can get out of this, I have it on a table.
Yeah.
Let me do that. Exit without saving.
There we go.
Here's our table, our skateboard ramp. Okay, so you measured the height. Okay, whoops, out of there. Measured the height, and then the length you said was 38 inches. Okay, and then because I'm starting at the bottom of the table or the top of the table or desk, we're starting with 0, 0. So then finding our rise over our run is a little bit easier because we might be taking 8.5 minus 0 divided by 38 minus 0, which ended up just being 8.5 divided by 38. So I got a decimal for our slope. 0.223. Okay, 3.6. Okay, and then I could come here and we'll try. I might have to use the keyboard. Do you want to show on here?
You want to do the speed?
Yep, let's do that.
Okay, and then that's this one. So this is so you get 2 feet for every 10 inches, you get a 2-inch rise. So we'll try the dump truck. I think that's the most well-behaved one, and with our rider. Are you ready?
Almost. All right. Oh, crash and burn.
Yes. She's okay, everybody. She's still.
Do we have our riders in there?
Yeah.
My little Lego
Yeah.
figurine. I do. Okay, so you had the dump truck, and
Okay.
I'm gonna go from this ramp
Okay.
because this guy, and my daughter said it's a Roblox something.
I don't know what
So,
that is.
but he's gonna ride a bathtub down. That's his fancy skateboard. Okay. All right. So he doesn't have wheels, right? So that's probably why it didn't continue on.
Yeah, it's a pretty tough transition there. If we try that, I'll hold it if you want to.
Okay, I try it.
Yeah,
Okay.
see if that's.
Oh,
So
still
we found
crash
something
and
part
burn.
of our design.
Okay, so let's adjust the slopes. So I'm gonna adjust my height. I'm gonna make it a little less, the height shorter, which changes the slope. Okay.
Right.
Do you want to try the dump truck? Let's
Sure.
see if it will.
See if it'll go up that one.
Woo!
Nice. Yeah.
Okay. And then if you had a rider, it would keep the momentum
We'll try it
going.
and see.
Okay.
We lost her
Yay.
hair, but I think she's okay.
Oops. That's all right.
And that was the fastest. So now if I decrease the slope,
Okay.
we'll try that.
Yes.
Okay.
And
so-
I'm going to increase my slope.
Okay.
And when you're building a ramp like this, those are the different things that you have to be aware
So
of.
you have to be careful of hitting the wall, as they say.
Yeah, so you don't want to hit
Which is the
undefined
undefined.
slope. There you go.
So
It
it
worked.
still makes a nice transition there. So we'll
Okay.
try again.
So as the camera's looking at the ramp on Ken's side, that is a negative slope going down. So I'm going to have an undefined slope at the other end, and let's see what happens. Brick wall.
Brick wall.
Right, it didn't go any further.
So suddenly,
Okay, I want to add just one really cool thing that I did see on online is let's see if I can slide this over. Some skateboard ramps, they don't want just a flat surface, but they'll have a curve to it also. Okay, and so an easy way is you pick a point out here, have a string there, and then you can draw
very
the
cool.
radius of a circle. But that's another homework hotline that we could do.
nice. So
So-
you can calculate the different ones on that. So,
Yeah.
very cool. And there's some really cool websites. I think I think there's some free ones where you can design your own skate park. Yeah. So
Yeah.
ramp plans online, and there's some that I know that have simulations, and so it's a lot of physics in there of you go to the top of a ramp and all your potential energy, and as you go down, it turns into kinetic energy and those. So
Well, as you're traveling around or out and about, even in your house, you're going to see different things that have different slopes
Right.
and how that makes a difference.
Right.
So,
and yeah,
okay.
we'll try it again.
Do you think it'll go this way?
No.
Oh, just a little bit. Bye, guys. Thanks for joining in.